Hello and welcome back to another episode of Humans in 5.
As researchers who are interested in human evolution, we're always looking for ways to test how humans have changed over evolutionary time. Biological anthropology is a field that is particularly focused on how these changes have occurred, but we borrow concepts and methods from fields like biology, ecology, chemistry, and many more.
We've talked about a few of these methods before, including using 3D scanners to look at body size and shape, and the many ways that we study the human skeleton, and how we can look at changes on the genetic and cellular level.
But today, we thought we'd focus on some of the methods we use to look at how humans have adapted to their environment. Whether it's hot, cold, in the mountains, or by the oceans, we live in many different parts of the world, and living in a variety of places has altered our bodies.
One of the first big theories that helped scientists think about climate adaptations in humans was actually borrowed from studying other animals. In 1847, German biologist Carl Bergmann came up with an ecogeographic rule demonstrating that generally, larger animals live in cold climates and smaller animals live in warm climates.
This rule looks at the relationship between body mass and heat. For example, larger-bodied animals like bears have a low surface area to volume ratio. This means that they have more volume or mass for each unit of surface area. This also means that they radiate less heat from their bodies and keep warm in cold climates. Smaller-bodied animals like mice have a little volume but more surface area over which to lose heat, meaning that they have a little trouble keeping warm and will be better suited to warm climates.
In 1877, American zoologist Joel Asaph Allen built on Bergmann's rule and suggested that animals that were best adapted for living in cold climates had shorter limbs, and that animals adapted for warm climates had longer limbs. Polar bears conform to this rule with their stocky legs and short ears, but this rule doesn't apply to every other species.
Naturally, researchers started wondering if these rules applied to humans and used a number of methods developed in medicine to look at differences in body size and shape. These included looking at limb length, height, weight, and fat distribution across the bodies of people living in radically different climates.
For example, researchers found that people living in high altitude in Peru had shorter limbs than those living in lower altitudes in the same area. Other studies showed that communities living in colder climates had, overall, a higher body mass index than those living in warmer areas. These are some individual findings. As always with humans, there are plenty of exceptions to these rules. There are also some issues with some of these studies. More recent work shows that many of these body mass and size differences relate to lifestyle factors like nutrition or economic status.
One landmark study demonstrated that Bergmann and Allen's rules are really inconsistent among human populations when we use a global lens. For example, there can be very different body proportions in the same climate. When we take all humans into account, other factors like nutrition and health status start to outweigh these 19th century rules. It turns out that different climate adaptations may not just affect body size and shape, but may shift how our bodies function. Researchers can use different equipment to test oxygen output and energy use when people are physically active in different conditions to look for differences in how our bodies function in these diverse environments.
It's been noted for a while that people from Tibet who live at high altitude don't struggle with physical activity regardless of the lower oxygen content of the air they breathe. Studies showed that Tibetans living at high altitude have larger lungs, higher lung function, and a higher amount of oxygen per blood cell than their peers living in the lowlands.
Of course, it's not just biological changes that have enabled humans to live all over the world. Building shelters, making clothing, and having a mobile lifestyle that can be moved with shifts in the season are also major behavioral adaptations for humans.
We hope today's episode has shown you some more of the amazing factors in human evolution and the human body. And we'll see you next time on Humans in 5.
And don't forget to subscribe.